After the discovery of the Higgs boson in 2012, we felt a little bit at the end of the story. In fact, it was only the beginning. These words from Laurent Vacament, Deputy Scientific Director of the French National Institute for Nuclear and Particle Physics in 2P3, where he is in charge of this second branch, sum up the mood among the 13,500 scientists, researchers or engineers around the world whose work depends in one way or another on the Large Hadron Collider LHC, CERN's giant particle accelerator, which has just come back into operation. The same one where the Higgs boson first appeared in the ATLAS and CMS detectors on 4 July 2012, after 48 years of Byzantine controversy and futile efforts, the end of history, because, as the 17th and last elementary particle identified 6 quarks, 3 types of leptons including the electron, 3 types of neutrinos and 5 bosons including the photon, the Higgs is the keystone of the theoretical edifice known as the Standard Model of Particle Physics. Without it, everything would have collapsed. With it, everything stands. Without it, everything would have collapsed. With it, everything holds together. This is why it was called the ultimate particle at the time of its discovery, with a few tremors in the voice and a touch of exaggeration. The beginning of the story, because this famous Standard Model, if it is coherent, is far from being complete, and physicists have known this for a long time. First, it only integrates 3 of the 4 elementary forces or interactions at work in the universe, since it leaves out the gravitational interaction, which is the exclusive domain of the theory of general relativity. Secondly, the 17 particles described by the Standard Model, which together constitute the fabric of which everything we observe around us is woven, only account for 9% of the total mass energy content. These 2 terms are equivalent for physicists of the universe. The rest, as we know, is composed partly of dark matter 26.8%, and partly of dark energy 68.3%, both of unknown nature. Outside the radar screen of the Standard Model is incomplete, to say the least. The latter is thus called to be one day or the other exceeded by a new physics, hence the rage with which physicists are trying to find flaws in it. And the world's largest particle gas pedal, the LHC, is the ideal machine for this. The good news is that after the technical shutdown and restart following the discovery of the Higgs, during what the machine operators call Run 2 or the second data acquisition period, 2 microcracks, yet to be confirmed, have appeared. This explains to a large extent the excitement with which these same physicists are approaching Run 3, which will start next July.